Now we're being asked to find an algebraic expression for the average rate of change of the function f at x equals 3x squared from the point where x equals 2 to the point where x equals 2 plus 8. And so we're given a number for x, but we're not given a number for h. So we're going to end up with an expression in h. Now, what we're going to do, obviously, is we're going to be using the difference quotient. Now in this case, we have an x, but no h. But that's not going to stop us. First of all, to make it simple, I'm just going to figure out what f at 2 plus h is. I'm going to find a nice simple expression for that. And so it's 3 times 2 plus h squared. Now, what I'm going to be doing is expanding a square binomial here. And so this becomes 4 plus 4h plus h squared, which is equal to 12 plus 12h plus 3h squared. There. I have the first part of the expression done. Now I'm going to figure out what f at 2 is. So f at 2 is equal to 3 times 2 squared, which is equal to 12. Now I'm going to be able to substitute into the difference quotient. So I know the slope, or the average rate of change, is going to be equal to f at 2 plus h minus f at 2 all over whatever h is. Okay, so let's do this. So my simplified expression for 2 plus h is 12 plus 12h plus 3h squared. And I'm going to be subtracting f at 2, which is 12, and I'm going to be dividing by h. And so I can see actually that I can simplify this part. 12 minus 12, handily enough, leaves me with 12h plus 3h squared all over h. Now I'm seeing an h that's common in the top and common in the bottom. And so what I'm going to do is I'm going to factor an h out of that. And so h, 12 plus 3h, there's the same expression, over h, and those are going to cancel, and I'm almost out of room, but I end up with 12 plus 3h as my final expression for the rate of change between 2 and 2 plus h for this function. And I can see that it depends on the size of h, and that just makes sense.